Hello everyone, I am Shalaka Deshpande. Welcome to my YouTube channel. So today's topic is port pin organization in 8051. Okay. So before starting this topic, there must be a question: what is this port? Port is a collection of input-output lines. Okay, there are input-output lines, and collection of those input-output lines is called as a port. In 8051, there are 4 ports. That is 32 input-output lines. Means 32 input-output lines. They are divided into 4 ports, and each port is having 8 input-output lines. Means port 0, port 1, port 2, port 3. These are the ports of 8051, and each port is having 8 input-output lines. Okay. And there are total 4 ports. 4 8s are 32. So total 32 input-output lines. Alright. So this is the division of the input-output lines. Okay. Now you must be wondering why the ports are used in the 8051 microcontroller. See, whenever you want to attach an external memory or external peripheral to 8051 microcontroller, they are attached via ports. Alright. And each port is having its driving circuit, buffer and control circuit. Okay, so buffer and driver is present. Alright, and whenever we reset any 8051 microcontroller, all the ports are configured as inputs. They act as inputs after resetting the 8051 microcontroller. Okay, so here it is very important that it is very important why the ports are used, and it is very important part of 8051 microcontroller. Okay, and now let's move on to this topic. Alright, so you can see there is a D latch. Every pin of a port 0 is having corresponding latch. Means now suppose there are pins P0.0 to P0.7. Alright, and each line is having a separate latch. Means for every line of a port 0, P0.0, P0.1, P0.2 till P0.7, every line is having a D latch. Okay, D flip-flop. It acts as a latch. Alright, fine. So what exactly happens here? Whenever this D latch, the logic 1 or logic 0 is clocked on this D latch via this internal bus. Because of the internal bus, the logic 0 or logic 1 is stored in the D latch. The corresponding write signals are issued to this D latch. Alright. Now, suppose I want to read the content of this D latch. So what will happen? This read latch is used to read the contents of this latch. Alright, this read latch has to be activated. This read latch signal needs to be activated. Now how do we activate the read latch signal? There is one instruction ANL P0, A. This ANL P0, A, this instruction is used to activate this read latch. Means what happens? Content of the port 0, that is input-output lines of the port 0, they can be configured as 0, 1 output or input. Content of the port 0 is ANDed with accumulator, and result is stored in the latch, and it is read. Alright, so this is how we activate the read latch by using instruction ANL P0, A. Alright. Now next part is read pin. What does a read pin do? Read pin reads the present status of a port pins of the port 0. Alright, and that present status, reading the present status of the port 0 pin lines and reading the latch is different. So understand the difference between read latch and read pin. Read pin is used to read the contents of the port pins present status. Alright, and this read latch is used to read the content of this latch. Okay, so that is the difference between the read pin and the read latch. Now can you see these two FETs? As I told you that every port is having a driver, and in the case of a port 0, these two FETs act as drivers for port 0. Alright, fine. Now how does it work? Now the port 0 work in 2 modes, normal mode and address data multiplex mode. Alright, sorry. In the normal mode, the port 0 pins act as normal input output port. You can use it for normal operations. But when external memory is interfaced to 8051 microcontroller, the port 0 works in second mode, that is address data multiplexed mode. We have seen this in the previous lecture, memory organization of 8051. Okay, fine. So the port 0 act as the address data multiplex bus, alright, in the external memory operation. Now what happens during external memory operation is, suppose the content of this, now you can see this multiplexer. Okay, when the external memory is attached, this multiplexer changes its path from the latch signal to address data line. Alright, means this output line is connected to address data line via multiplexer, and this is disconnected when they are doing the external program memory operations. Means it happens like this. Now it is here, then it will move like this in external memory. In external memory operations. So the multiplexer changes output line from latch to address data lines. Alright. Now the game is on. Now what happens? See, when this address data line is logic 1, when this address data line is logic 1, via this AND gate, this upper FET, which is a upper driver FET, is activated. It is on. When address line is logic 1, this upper FET is on. Alright. And when this address line becomes logic 0, this upper FET becomes off. Okay. And when this upper FET is on, means this upper FET is active. Alright, when it is active, the port pins get converted into output pins. The port pins are configured as a output pins. Alright. Now suppose I want to make the port 0 pins as a input pins. Now what will I do in that case? Suppose the logic 1 is locked inside this D latch via internal bus. In that case, when the D is logic 1, this again moves to the previous position. This will multiplexer moves to the previous position, and this logic 1 will be carried like this. NOT gate turns it into 0, and when NOT gate turns it into 0, logic 0 is applied to this bottom FET, and because of that this bottom FET is off. And when it happens, when the logic 1 is clocked inside this D latch via internal bus, this port 0 pins act as a input pins. Alright. So whether the port 0 pins will act as input or output is decided by these driver FETs. Alright, now next part, whenever the port 0 pins act as a input pin, we will require a pull-up resistor. And how do we connect a pull-up resistor? What is a pull-up resistor? See, pull-up resistor is connected between the port 0 pin and the VCC. Between the VCC and the port 0 pin, they are connecting the pull-up resistor. It acts as a bypass to pull-up upper FET. Okay, and now you must be having question, why the pull-up resistors are essential. Now, as you know that the port 0 or any other port, we are used to connect the external device to a microcontroller 8051. Alright. So the device is having something different operating voltage, and operating voltage of microcontroller is different. Suppose the device is having high voltage. So to pull the port pins line to the desired voltage, we are having pull-up resistors. So the voltages between the microcontroller pins and the device, external device, should match. So the pull-up resistor pulls the output pins, input pins to desired voltage. Alright. And the communication between the external device and the microcontroller takes place. Alright. Now there must be one more question before you, that I mentioned that every port is having a buffer associated with it. Okay, now what is this buffer? Buffer is a logic circuit. Okay, it amplifies current and power. Buffer is a logic circuit to amplify current and power and to increase the driving capability of 8051 microcontroller. Alright. So that is a buffer. Now one more thing is there. You must have heard the word high impedance state. High impedance state is a term when the input output line is neither logic 1 nor it is logic 0, it is floating. When that line is floating, it is, we said that it is a high impedance state or tri-state. So buffers are generally in tri-state. Alright, we use buffers which are in tri-state. Tri-state buffers we call it. They can be unidirectional and they can be bidirectional. In most of the applications we are using tri-state buffers. Okay. So that was all about the port 0 pin organization of 8051 microcontroller. I hope you liked the video. If you have any doubts, you can ask me in the comment section below. Alright, and please like, share, subscribe my channel. Thank you for watching. Bye bye.